I know I have not explained the square bracket, what it does. I have not explained the bar A bar. But this code is all that you will need regardless of how many variables you're dealing with. This code will work when you try to find a maximum of 5 variables. It will work when you want to find a maximum of 50,000 variables. It will work when you have 5 billion variables and you want to find the maximum of those 5 billion variables. The amount of time it takes to execute will be proportional to the size or the number of items, but the code itself does not change. Okay? So are we starting to appreciate why arrays can be helpful, even not understanding what it is or what these particular notations represent? Yep. Okay, very good. Because I always want to start with a rationale, why do we need to know this sort of thing? This is more than enough to convince me. Okay? So now we go back to the notes, just for the reference of what is an array. But before we do that, we'll do that anyway, but we'll do it later. Before we do that, let's go ahead and take a look at a picture, a pictorial representation of what an array looks like. At this point, we talk about variables. We talk about W, X, Y, N, F. Those are all variables. Each variable, you can look at it kind of like a container, like a cup, a coffee mug of some sort, and each one has its own name. Okay, we have N, we have F. So each one is individual, has its own name, so that when I say, okay, I want to add one to F, I can tell which variable has to be affected. Okay, so this one is variable F, and it is the one, only this one will be affected when I say F gets F plus 1. An array is a box. Okay, so this is a completely new concept in programming. It is a box. If I say that A is an array, then I'm having a box named A. Okay? But what is special about this box is it is a box to contain these other containers. So I can now have a box that has 3 coffee mugs inside it. And the coffee mug inside the box do not have names anymore. They don't have names like X, Y, Z. They don't have names like N and F. Instead, they are identified by a number, by what we call an index. The first one has a number of 0, the second one has a number of 1, and the last one, in this case, has a number of 2. Okay? In this case, when you want to refer to a particular coffee mug, you can say coffee mug 1 of box A, because you can have a box B that has its own coffee mugs, a box C that has its own coffee mugs. To identify a specific coffee mug, now you have to specify the box itself as well as the number that identifies that container within the box. Are we doing okay so far? Okay. So that basically kind of explains what the notations are for. A bar is the number of elements inside the box, the number of containers inside the box. In this case, bar would be 3 because we have exactly 3 items inside that box. Okay? I use the bar notation because it is kind of like doing the measurement thing. So that's why I picked its notation bar, which is normally used as the absolute value in a math class. But in this class, I use it to represent the number of items inside an array. The other notation is how do we designate a particular coffee mug? How do I say I want coffee mug 1 of box A? That will be the square bracket notation. When I say A square bracket 1, that means I want to use coffee mug number 1 of box A. Are there any questions about the notations? Only two new notations are introduced. One is bar, which returns the number of items inside an array, and the other one is A within square brackets, an integer, which helps me identify which coffee mug inside a box do I want to access. Are there any questions about the notation? No notation? No questions? Okay, so when we go back to the notes, there are other things that we have to understand about arrays. all elements inside an array must have the same type. So that means I can only have integers inside the box. I can only have booleans inside the box. I can only have real numbers inside the box. I cannot have a mixture. I cannot have, oh, this one is a boolean, this one is an integer, and this one is a real number. That cannot happen. They all have to be of the same type. The second restriction is each element has an index. Basically, each element inside an array is identified by a number, an integer that goes from 0 to some other number. The index of the first element is 0. Now that's kind of funny because naturally we do not count from 0, but in programming, at least with array indexing, we count from 0 all the time. Okay. Can anyone kind of guess why we are always counting from 0 in programming instead of counting from 1? No?
Because 0 is positive. Because 0 is considered positive.
Not exactly. It is because 0 is the beginning of something. Okay, it's the beginning of something. You may not understand why we choose to begin with 0 until we get to the assembly programming class, where it will become really obvious why we have 0-based indexing. Yep. Okay. The next restriction says that indices, the plural of index, of elements must be contiguous. In other words, you cannot skip numbers. You cannot say, I want the indexes to be 0, 2, 4, 6, 8. Nope, cannot do that. It has to be consecutive. And then this one, we have talked about it already. Bar A bar indicates the number of elements in the array A. This one is basically, you can imply this one from the earlier ones. If an array has bar A bar elements, the index of the last element is bar A bar minus 1, which makes sense because in this case we have an example of 3 elements in an array. The index of the last element is 2, and 2 does equal to bar A bar, which is 3 minus 1. Are there any questions yet at this point? No questions? Okay. The last one is perhaps the most important part, and it does not look like it is very important. The important part is to remember what you put inside a square bracket can be anything. It only has to be something that evaluates to an integer value. In other words, 1 is a constant that is an integer. You can also use a variable. If I is a variable and it is an integer, you can use I. You can also have an expression this long involving 20 different variables in a calculation, 16 levels of parentheses. As long as the result of that expression is an integer, guess what? You can put it inside the square brackets. That is interesting, and it is also what makes arrays very useful. It's because which element you're accessing depends now on the calculation of its index, which means the same line of code can access a different element at a different time. Are we okay with that concept so far? Okay? So just remember, inside the square bracket can be anything that evaluates to an integer. It can go from something as simple as a constant to a huge long expression. As long as it is an integer, you can put it inside the square brackets. We will go to a sample program next. It's already in the text, so I will just kind of copy it into a spreadsheet and trace it. Because we want to understand how arrays are represented in a trace before we can go any further from here. Okay, so now we are going to write a very simple algorithm. I start with I gets 0, while I is less than bar A bar do. A bracket I gets, well, we'll put a 0 here just for the time being. And then we have I gets I plus 1, and while, and then give it line numbers. do the indentation. There we go. The purpose of this example is to illustrate how do we represent an array in a trace, and what do we do with the indexing operator. I think that's that's one of the big mysteries of arrays. We have variable I. Now, in this case, variable I is an index variable, but in the context of the program, it really is just a regular variable. Okay, it's no different from the x, the y, and the so on, n and the f that we have used before. It's just a name of a variable, and the type is an integer. Now, how do we represent array A? Array A, I have to tell you ahead of time how many elements are in A before you can trace an algorithm like that. So I always have to give you a precondition of some kind, at least to tell you how many elements we are dealing with. Let's just say that we have 3 elements in this case. When you have 3 elements and each element is an integer, you need 3 columns. Because each element inside an array acts and behaves just like any variable. You can see it from this picture here. Each element inside the box is just like a coffee mug, a cup of some kind. So whatever you can do with an individual variable before this class, you can do it to an element inside an array as well. And that is why in a trace, every element has its own column because it is a variable on its own. You can look at a bracket 0 as a variable just like any variables we have seen before, except it has a funny name. Are we okay so far? Okay. Look at this as Borg, 7 of 9. This is 0 of 3. Nobody's getting the joke. Okay, so O, M. I'm just merging these 3 cells together to represent it. The entire array consists of columns D, E, and F, but each individual element is taking a column. A bracket 0 is using column D, A bracket 1 is using column E, and A bracket 2 is using column F. Now we have to go take a look at the algorithm and see what it's going to do when it executes. It's because when I do that, it resizes all the columns at the same time. Not what I want to do. Okay, yep. All right. Let's talk about the precondition. Now that we know there are 4 variables that we're dealing with, do we have to specify a specific value for I? No, because the first thing we do to I is to overwrite it. Very good. And the same thing with all the elements in the array, because you can see that the only type of access that I do to the array elements is to overwrite it with a constant of 0. Which means I don't need to know what is before that statement, and it's not important to know it. So we can put question marks in all columns in this case. Line 1 is initializing I to 0, so I becomes 0. Line 2 is asking I is less than bar A bar. Is that true or is it false? What is bar A bar in this case? What is the number of elements in the array? We got 3, and I is 0. 0 less than 3 is true. Very good. Then we go to line 3. Now, what are we doing? We are changing which column? Well, what is I? What is the value of I at this point?
0.
I has a value of 0, so A bracket I is referring to A bracket 0. A bracket 0 is in column D, so we are putting a 0 in column D in this case. So I would